So you want to check if the given integral is divergent or convergent. You realize that the discontinuity point is going to be at x is equal to 1, right in between these two limits of integration, right? So you have to break this up from 0 to 1, and then add that from 1 to 2, like that. Okay, so now introducing the limit for the troublesome 1 there, right, approaches 1 from the left, right, so from 0 to r. So that's going to be x over x squared minus 1 dx plus the limit as r approaches 1 from the right, right, because 1 is the lower limit. So r to 2 x over x squared minus 2 dx. Okay, so using the u substitution, we know that u is the bottom, du is going to be 2x. There's no 2 there, so we will have to, since there will be a 2 in the du, we will have to have a 1/2 outside of the integral, right? So we will have 1/2 the limit as r approaches 1 from the left, and 1 over u is going to be the integrand, right? Because you're using the u substitution, and the derivative of 1 over u is going to be ln u, right? So we will have ln, and let's have absolute value bar, because when x is equal to 0, you will have -1, and inputs of ln's can never be negative, right? So we have to have absolute value bar x squared minus 1, right? Because ln u is the x squared minus 1, right? Evaluated from 0 to r. And same thing again, there's a 1/2 coefficient plus 1/2, right? The limit as r approaches 1 from the right, and that's going to be ln again, absolute value x squared minus 1 evaluated from r to 2. Right, so then we would have what? If one of these guys is divergent, then the original one diverges as well. So we will have 1/2. Let's see, so that's going to be so ln of r squared minus 1 minus ln of 0 squared minus 1. Let's see what happens here. I forgot to write the limit, didn't I? Okay, so let me write the limit here. So that would be 1/2 limit as r approaches 1 from the left. Okay, so what would that give us? That would give us 1/2 that would give us what? ln of 1 minus 1, 1 squared is 1, 1 minus 1 is 0, ln of 0. That's it. That already tells you this is negative infinity, right? This is already sufficient enough to tell you that there's divergence just because of this negative infinity, right? Because negative infinity is not a quantity, right? So there is divergence. Since there's divergence, no matter what happens in the other parts, there will be divergence of this original integrals, right? So we say that the original integral from 0 to 2 of x over x squared minus 1 dx is divergent. Thanks so much for watching. See you in the next video.